Weird. You're going Terraform. Okay. Then let's go Terraform with the goal of, so first of all, let's define some sub goals. Terraform. So one thing that I did already, so I have at least a reference, is deploy Docker containers locally or from a CLI. So it's first off, it's kind of replace Docker Swarm or Docker Compose. Essentially, that's kind of the first step I think that we can look at, which means we deploy some Docker containers locally, say MongoDB, as well as Mongo Express, which is a administration tool for MongoDB, and I don't know, in one application that uses the MongoDB OJS application that uses the MongoDB, and that's one part. Other than that, we can try to do an AWS as first EC2 and then upgrade AWS S3 bucket and do that automatically. Yeah, I'm kind of worried about the time. Shall we skip this and dive right into it? Because I kind of, again, worry about whether we are able to go this whole way. We can also smooth this out and just like do this, which would also be all right already. Sounds good? Which one? Actually. So start with one or start with two immediately? Choice is yours. Start with two immediately. And we remove this one. And yes, I just hit the comment button and learned that in Markdown files, you can actually do comments. Cool. I didn't know that. All right. Then we do EC2. So what I do have, let's maybe start very, very basic by just going to terraform.io and paste this into the chat. So what it says is, well, it's open source, okay. Infrastructure as code, which is a principle that there are multiple DevOps principles. One is your infrastructure is just cattle. You don't, they are not pets, so it should be replaceable as much as possible. If you need a new container, you throw out the old container and just take a new one, not like your favorite cat or your favorite Tecan. Instead, you do it like coffee. You have your coffee mug, but it looks like 20 of the other coffee mugs your girlfriend bought to you, or your grandmother each year. She presents you for Christmas. She gives you the same coffee mug, and you have like 20 in your shelf already. And whenever one breaks, you just take a new one. And infrastructure as code builds on top of that idea. Everything you do, you type in code. You put it into GitHub, at least a large part of it. Everything that does not contain credentials, of course. because Git is not a place to put credentials into. And yeah, then you essentially run one command and everything is online. And that's the basic idea of Terraform. Well, yeah. So what else does it say? Infrastructure as code tool that provides a consistent CLI workflow. Yeah, so everything is CLI to manage hundreds of cloud services. Terraform codifies cloud APIs into declarative configuration files. Yeah, so we don't have to do click ops and click everything together. Essentially, we rewrite files like this. Oh, let's make it slightly larger. This is basically already all we need to do. Is you define that you want an AWS instance, which is a EC2 bucket, the EC2 instance. And this is, I think, just the name. You define the image. AMI stands for Amazon Machine Image, which is basically a Docker image, but because we're talking virtual machines, machine image. Not 100% sure what this does. Availability zones is like, where do you want to do it? There's also region, thinking about it. So maybe this is, again, something else, slightly different. I think all of this is already optional. All you really need is just this one, and then you run one command and everything works. So I do have Terraform already installed. If you don't have it, let's go into the tutorial section. Oh, give me just 1 second to finish anything down here. Yeah, so the basic workflow is that you usually write these configuration files in this domain-specific language, HCL, HashiCorp config language. Then you hit Terraform plan, and it prints you out what it will do. Everything that changed will be displayed here. In this case, there's just one instance that is created, so there is nothing to change or to destroy. And then, well, you read through it. You basically could do a PR review, pull request review, and then say, okay, now do it, apply, which is Terraform apply. They don't have a picture for it, but instead of plan, you write apply. And that's pretty much it. You have an AWS EC2 instance. Let's dive into the tutorial and go with the AWS tutorial, which I also have open here, but it's fine. So there are also nice let me share this link, and we start from the very top, essentially. So it explains what infrastructure as code is. I did that just now in the introduction. Workflows, let's see. Simple workflows for deployment will follow closely. Okay, yeah. Advantages, so it is platform agnostic to a degree, to be honest. Azure still exists. Yeah, Azure is a big thing. Yeah, I would even say Google Cloud Platforms less than Azure. But maybe that's, let's say it has less market share. But I'm not 100% sure. Market share cloud providers. Do we have a nice graph here? We don't. AWS versus Azure versus Google. Tell me the numbers, please. Just make it a graph. Here. So in Q4, this is US dollar. Azure is way above Google, Alibaba Cloud is like Chinese. Alibaba is one of the biggest Chinese. They do everything, I think, to be honest. But they are mostly known for the shopping, like everything that goes into the direction of dropshipping. They are very big. Or you can just buy like complete houses and big machines on there. But strongest is of course AWS. Yeah, but Azure is a big thing. No. So to give you that one, I don't know how big Park My Cloud or how respectable Park My Cloud is, to be honest. So you might want to double check whether this is true or not. But if they are right, Azure is a thing, big thing. Back into this. So it does say it's platform agnostic. So far, I did work with Docker, saw some Kubernetes as well as AWS stuff, but that was essentially all specific to AWS, Docker, and Kubernetes. So I'm not sure how much platform agnostic it is, but maybe in the following steps. I'm also a beginner. I essentially did this tutorial. Other than that, I have no idea. It does manage the state, which is cool. So whenever we apply, it will create a file which has all the relevant information. But it also includes some security relevant stuff, like keys and so on. But for example, what's the ID in the instance ID? What's the public IP of the EC2 instance? We will see a lot of that in a moment. Operator confidence, yeah, it's definitely more shareable. You don't have to do ClickOps. Avoids a lot of human errors. Nevertheless, you still got to be kind of careful, of course, because you do change the whole infrastructure if you run Terraform apply. Okay, thank you for the information. How to install it? I did do that already, so I'm on Linux, which means I essentially just added the public key and the repository, and then installed it via sudo apt-get or sudo apt install. That was pretty much all the installation that was necessary there. Tab completion comes as well. So I did set up a nice, inside of my aliases, I did set up a nice alias for Terraform called TF. So if I write TF plan, it's basically the same as if I write Terraform plan. Saving myself some time. And then we get into the quick start tutorial, which is Docker. So what we see, and let's go over it kind of quickly because they introduce a lot of stuff. So what they have is kind of 3 parts. There's the configuration files that we write. Components. Let's call it components of Terraform. Part 1 is the user provided ones, which is configuration files written by us. Then there's the Terraform core, and it does some amazing stuff. We will get into that in a moment. And then there are Terraform providers, or I don't know whether they're called Terraform providers, or just providers, which is essentially plugins that connect your configuration and the stuff that should be built which then connects it to, for example, AWS. So there's a AWS provider, or a Docker provider. There's also a Minikube provider, for example, to build Kubernetes on your local with Minikube, or etc. There are a lot, I think, like not like Docker, Terraform providers repository. Yeah, so here's a list of all providers that they have, which they provide. Of course, the big ones, but also smaller stuff. I don't know. Nomad is apparently by HashiCorp themselves. So these are probably all the featured ones. These are verified providers. For example, I don't know, Big IP, Brightbox, all stuff that I don't know anymore. But they are supported. Launch Darkly is even here. Interesting. New Relic, Metal. Yeah, so they have a lot. Grafana, GitLab. Exascale is one that I've worked, cloud provider like AWS alternative, but a lot more secure, but also smaller. Yep, Cloudflare stuff. Okay, from this, so the basic idea is we write this, we run a Terraform command, it builds us together with the state files maintained by Terraform. So these two kind of feed into the core, and then it determines like the steps that it has to take. For example, if we already have an EC2 instance that is defined in the configuration files, we don't need to create that again, right? But if we define another one, we do want to create the second one without changing the first one. And Terraform core figures all that out. It also takes care of dependencies like this service A has to be deployed first, then it has to create like a gateway, and then it has to create like, I don't know, some numbers and an S3 bucket. And it figures everything out and makes it as fast as possible, parallelizing as much as possible. Which then feeds into the providers and they do the actual work. And then you wait a few seconds or minutes, depending on what you're doing. And voila. So, the basic form, let's create like, make a directory, E6 Terraform, perhaps. And let's move into that directory, which is T and TypeScript, Terraform. Okay. Yes, I do want to change, save the changes. So, code /e6. Code /e6.md. So I do want to have this file. Other than that, I have essentially an empty folder. And the first thing I intend to do is run. I'm not sure whether the order is correct, but I think, run Terraform init. Initialized in an empty directory. Okay. Directory does not have config files. You may begin working with Terraform by creating these files. Did it do anything? No, so far it did not do anything. Okay, then let's make a file which we call main.tf. TF stands for Terraform. as you might have guessed. I do have the plugin installed, by the way, the official one, HashiCorp Terraform plugin. If you follow along, but I don't know, sometimes it works and then it doesn't. Let's see. So what we want is we do want to define some providers. And one thing that I'm always confused about, in this case, we don't need an equal sign. We define the provider in here, and then we define details about the provider, like so. So we probably want to provide AWS, and then it has probably a source. We will see in a minute. And then we want to define this provider here more specifically. I think what we need to provide is a region. Let's say EU Central 1, which is Frankfurt. Maybe not go there. Let's do US East 1. And I also need different parentheses, quotes here. So in this case, so we do define the required providers, which just tells Terraform which plugins to load. Else, I mean, of course, it will not download all the plugins if you don't need them, right? As soon as we have the proper AWS configuration, let's see, here, this one, that's the one I want. And one thing that we can do as well is define a version to avoid that we break. So this is a tilde greater than, instead of, I don't know why I think it means greater or equal, but I don't know for sure because they wrote it ugly. I don't know why they didn't use an equal sign. Maybe, no, I don't know. Other than that, okay, so we also need to provide a profile here. We can do that easily. Save, and from that point on, I think the auto-formatting did work now. So there's also a Terraform format command, which of course did nothing right now. So if I save this ugly, formatted, it does nothing. Okay. Let's save it ugly again. Terraform format. That's nice. So let's define that here. Commands. We have Terraform format. The context. Rewrite bash. Like so. Then rerun Terraform init. Because so we now defined the providers. And now we have to download them, these plugins. And I think this is done by doing so. Apparently it's called providers. So yeah, one cool thing is most of the time, let's say, it tells you when there are configuration problems in the sense of syntactical problems. For example, this needs to have an S. So this is an object with multiple entries. For example, we could also define Docker inside of here, which we will not do now. So second try, tf init, initializing provider plugin, initializing the backend. Not sure what exactly that means. It also created a few files, like a log.hcl file, which is allowed to go into version control. And yeah, include this file in your version control so that Terraform can guarantee to make the same selections by default. When you run Terraform in it. So it's exactly like the, what's it called? Package log or yarn log file. But for Terraform versions. So in this case, it apparently installed version 3.37 because the constraint that we did define was greater than 3.27. Coolio. It also downloaded this file, which we want to put into, oops, my bad, .git ignore, which is .terraform. Did that work? Yeah, it worked. Okay, cool. We do have some more files that we want to ignore. Okay, so far we can initialize. Then Terraform init. Initialize plugins, etc. And from now on, we can define what we actually want. So they call this resources. And in this case, we do want an AWS instance. And I do have auto-completion here as far as AWS, remember? Or this. Module Terraform resource. Anyway. Let me just check one thing. Let's do it like so. And we want AWS instance. Okay, I don't know. Where does it put this around there? So to a degree, last time I got it working again. I don't know what exactly is happening with the plugin, but sometimes you get auto-completion, and sometimes you don't. Let's call this TypeScript T time. And I don't know whether this is just a convention, but they use subscript to most of the time. Race is great. Welcome to the stream. We are today looking at Terraform, which helps us with providing, like, managing our infrastructure. So everything that has to be hosted. There's also, everything that when you put it into production or into development on the internet out there, everything that's useful there. But also for your local stuff, in fact, like not a replacement for Docker, but an addition to Docker. Let's save this. And one thing I want to try is just reload the window to see whether maybe, we did it. Auto completion, at least to a degree. So let's look at the tutorial, what we actually need. So we do need the AMI, which is the Amazon machine instance, which is essentially the Docker file, Docker image. But since we're not essentially like Docker image. And so there's usually AWS. So these in particular are specific to the region. So we need to be careful with that. You're here a while. Okay. Oh, I didn't see that you answered as well, because everything is green. I thought it was still. I thought it was the HCOR storage. Sorry for that one. My bad for missing that. Yeah. So these AWS instance. Look. Yeah. These files are specific to regions, so we have to be careful with that. In this case, this does not exist in here, but for example, from this list, we could pick something. I don't know really how to determine which one you would choose, but it's definitely possible somehow. But for this one, so this is an Ubuntu instance. I know that. Ubuntu 12, I think. 12. Which is kind of old, but well, whatever works. The instance type is how large should the machine be? Like you can have a machine with powerful, I don't know, 128 gigs of RAM and lots and lots of terabytes of space, disk storage, and whatever. But in this case, well, we only want to display it, right? So I just picked the simple one. It costs a bit. I think having it, they bill you per hour, and this micro instant, like it costs really nothing. It costs less than a cent per hour, if I remember correctly. Other than that, we can define some tags so it's easier to find. Let's give it a name. Let's give it a name of TypeScript TTime is awesome. Like so. And I think that's essentially it. So again, this essentially defines how Terraform should work and which providers are needed. Then we configure the provider itself. And that's why I said it's so Terraform said it's platform independent, but to be honest, this, for example, is obviously not platform independent. This also is not really platform independent because it's specifically AWS instances, and they will probably not work on anything else than AWS. But there are other examples which are more agnostic of the actual platform. For example, if you go into Kubernetes stuff. Did I forget anything? So the Terraform blog, the providers blog, resources blog, init, we did that. Format, we did that. We can also validate manually. Yeah, validate, Terraform validate. Configuration is valid. Let's include that. Terraform validate config. Did I save? Yeah. So far it's okay-ish. You still haven't seen it in action, but we'll do that in a second. Yeah, right now. So far things are clear, because now I need to log into AWS. US West, not, but whatever works. I do want to log in as root user. Oh man, captchas. BAMS. And now I need to provide my multi-factor. You can of course see this because it's one time only password. I don't care if you see it. The real password is of course restricted, and you would need to have my second device. So I did set this up, and by the way, before you can actually use AWS, you also have to install the CLI, the AWS CLI. I did forget that. And you have to set AWS configure. It creates a file .aws credentials in your home directory. So I do have that in my home /AWS, like so. Yeah, so there's the file. How it essentially looks like is like it has a secret similar to env variables, and that's something, and it has a AWS key, I think, which is also something, and that's all that's inside of the credentials file. It's all automatically created with this after you installed the CLI and run AWS configure. I think you then get redirected. It's really not that hard, at least not on Linux, but probably Linux is the hardest one. So here, yeah, you call some install file, you unzip it, and then you run install. That's pretty much the complete install. If you're on some fucked up stuff like Arch, I can't guarantee how it's going to look like, but people probably came up with a solution. And yes, you have to have set up an AWS account. One cool thing is there is a lot of free contingent. Unfortunately, this is the German page, but hopefully you just get redirected to the maybe let's take this link here. AWS is for the first 12 months and even after that, for the first 12 months they give you a lot, 750 hours of these hosted instances, 5 gigs of space. This is a relational database service, so like a Postgres. You can host a lot of hours. This is essentially 1 month. I think you have one Postgres free per month, 24 hours. DynamoDB, and it's kostenlos forever. So immer is the German word for forever. And Lambda functions also 1 million calls. Well, let's see, 1 million compute units for free. I also set something up, like it doesn't run too much, but for some reason I have 25. I am charged 25,000 compute instances. So be careful what 1 million actually means. Nevertheless, my Lambda functions are very, very, very slow, and I should make them a bit better. Okay, so that heads up gun, we did set everything up. Again, the questions to you guys, did it make sense so far? From now on, I will run this apply command. It's cleared for a second. And let the magic happen. So let's go to, did I say US East West? Let's go to that region, and you see that I have nothing in here. And now let the magic happen. So usually there's also a plan. And the good thing is, until we type this yes into it and approve on our changes. This is essentially running plan. And it tells us what it will do. So everything with a plus it will create. So it will create this AWS instance, and it already knows the machine image. ARN, I don't know what it is, but it's also only known after we actually have deployed it, because AWS assigns it dynamically. The public IP address also will be displayed after the fact. There's also other store. How much CPU do we get? This is, I think essentially determined by our instance type. Some ID, probably the most important information. The instance type, however, is known. And some more information: public DNS, public IP. So the human readable and the non-human readable stuff. And the tags that we defined. It also creates some more. I don't know what an EBS block device is. You can probably find out. What does that mean? What are EBS block devices? What is elastic block storage? I want to go to English. Please, thank you. High performance block storage. So we get actual storage attached to the machine itself does not have storage because it's a virtual machine. The thing that we define here with AMI. Attached to it, we get some storage. Volume ID, volume size will probably be interesting, which is also defined by our instance type. Enclave options, I have no idea. Ephemeral block devices, also storage, some metadata, network interfaces, all that stuff. It looks good. I mean, it will create everything for us. And all we need to do is type yes. And now we wait for a few seconds and get an error. Invalid AMI ID found. Maybe I messed up copying all because again, AMIs, the images are specific to, they are specific to the region, and I messed up the region here. Let's go to US West 1, and let's go to US West 1 in here as well, and see I have nothing there. And so I correct this region. Now the image should exist. Let's clear here again and apply again. So it does the planning again. And we looked at it already, so let's say yes this time. This time it works, creating, and in the meantime I pour myself some tea. I'm not sure whether the noise gate might capture it. I hope you had some ASMR here. Yeah, for an EC2 instance, I think most of the time it took like 30 seconds. Yeah, 31 seconds here. And that's it. Let's look at it. So I can reload here. Oh, I could also have clicked that button. And there it is. We now have a server running on AWS without even having touched anything in this terrible forest of AWS configuration and the UI. So no click ops, and this is one of the great strengths, I think, as well as we can just put this file into version control and other people can run it as well, reuse it, and so on. So yeah, as you see, it's an Ubuntu instance running yeah. Since it's Ubuntu, of course, it's running Ubuntu Linux. We have some addresses here, but I'm not sure whether anything is actually running on that. So I'm not sure whether we will see anything relevant here. I mean, we can probably ping it. If we do, let's see, ping this, do it, not known. -4. Oh, my bad. So ping -4 uses IP4 instead of 6, not known. If we provide the address, does that work? Ping -4. No, it doesn't. Okay. Yeah. So it's not yet reachable. Some more configuration would probably be necessary to do that. I'm not sure what it's actually running because I don't know what's inside of the image. Apparently it's Ubuntu 12 AMD server with something. I don't know, we could search ourselves in AWS AMI with WordPress on it. And and if we take that one, so it costs, well, 2 cents per hour, which I can live with. How do I use this? View usage. To subscribe. AMI WordPress Ubuntu. Yeah. So what I was hoping for is to see, to have an image that essentially like Docker, you have an image that already contains everything. That was my hope, to easily find it, but I can't really find it. Yeah. We could, if we define some more stuff, we could connect to it via SSH. As of now, I think it's disabled, so we cannot log into that right now. I think that's visible inside of here. No IAM roads, networking, cloud ID. Let's check monitor. Any ideas where this was? Anyway, so what we did see, it's very easy to set this up. Apparently finished also to status checks. And in particular, we can also shut it down immediately. If we don't need it anymore, we can just see. Okay. Yeah, let's not shut it down immediately. One important thing here is that we now have state. Previously, the state was empty. So we do have this file terraform.tf state, which contains, sorry, this one, which contains some private information. So I'm kind of worried about showing it. Give me just 1 second here. Yeah, I think it's fine. We will shut it down in a second anyway. It contains a lot of information about how was it hosted, as well as, and that's the most important part, what is actually created, which in this case is AWS instance, and it has the ID inside of here somewhere, which it uses to identify. And if we now, for example, let's say, yeah, and it all keeps track of this. One important thing about this is that this file is private, so you should not put it into version control. There are some other forms of that. For example, Terraform Cloud and Terraform Enterprise, which handle this for you. Because in Git, you should not put any credentials, but these guys handle this for you somehow. Magic, I don't know what they exactly do. Probably they also just run a kind of secure version of Git or something. I don't know. But inside of there, it's definitely encrypted, all the secrets, which makes it a lot more secure, while Git would not be encrypted. Yeah, they call this remote backends, by the way. So if you're interested in that, here's more about it. You can also choose to use others, I think, and not go with like Terraform and Terraform Cloud and Terraform Enterprise. Of course, come from HashiCorp themselves, but there are probably others that do that by now. So, yeah. We can also run Terraform show to just look at it, but it's a file, so we can just look at it inside of our VS Code as well. So, and finally, Terraform state lists then all the resources that we have defined. Particularly, we could have more. For example, let's do it. I mean, nothing stops us. Let's add Docker inside of here and define the source to be, oh, what's it called? I think it's Kreuzberger or Kreuz something. Look at this first tutorial here. What, second one? Third one? Yeah, this one. Kreuzberger. Docker. And again, so we define now a new provider, which is Docker. We have to configure the provider. The good thing about Docker is it does not have to be configured, or all the defaults are fine. And then we can define Docker resources, which is the Docker image. That's written correctly? Yeah. And what I want is to have nginx in here. I suppose it's image. Oh, it's name, okay. Name. Nginx, it's actually, I call it nginx, but I call it nginx because it's shorter. So the name is nginx/latest. We can just look, and it would pull it from Docker Hub. Well, let's use Mongo because we can. Let's use nginx. Nginx because it gives us very simple a web server which we can ping. Docker pull nginx. Yeah. So this should work. Do I have to provide anything else? Keep locally. Well, do we have it? Docker image list. I don't have it. Let's ignore it for now. So we don't want to keep the image locally. So I don't need to allocate 100 200 byte there, megabyte. And well, Docker without a container is nothing, right? We do have the image, but we also have to define the Docker container. And let's call it also just engine X, I guess. I'm not sure whether maybe we get a name clash, but let's see. What do I have to provide for that one? Of course, the image. Yeah, in this case, it's the image. And the image is engine X, which is this. Okay. So now we get into some more specific HashiCorp configuration, .terraform file. So we can now reference this one by docker image.nginx. Other than that, we give it a name, TypeScript, time, gateway, let's call it. And probably some tags. I don't know, right. Usually it would just be the container, and it does not have any ports connected on our local machine, so we couldn't access it, which is of course not what we want. We want to have, is it internal and external is 8080. So internal is what's the port that we talk on inside of the container, and because it's a web server, it runs on HTTP port 80. And this is the port that I am able to access it on my local machine. So if I write into my browser localhost 8080, it will forward it to container 80, which is running the web server. So that's how you need to read that. So we still have this instance running, but now we define new stuff, and now the magic happens. If I do Terraform plan, I have to write Terraform init because I added a new provider and it has to install it. My bad. So that worked. And in this case, we should see not only AWS inside of here, but also Docker. There it is. So this one's new. Let's put .terraform star.tf state inside of here. Why are you not? Because it's .backup. Okay. Star. Yeah, that works. You, as well as you, as well as you. So close everything down. We did install the provider now. Now we can plan. We have plan. This is again an implicit step if you run tf apply. Let's run it separately just for now. It now does some planning, and in fact it has to do something, right? In particular, also it refreshes the state and it fails. Okay. It refreshes the state. For example, inside of AWS, if I would have manually gone inside of here and deleted it, instance state, stop it, for example, then some properties would have changed, and Terraform needs to update all those information because you always define what you want with the help of the configuration, and as soon as you run apply, Terraform, at least in that moment, will make sure that it's being done, and that you're again in that state. So one thing that can happen after you initially ran apply is that the containers changed, or that the EC2 instances changed, or I don't know, something else burns down or whatever. In that case, the next time you plan or apply, it will update with all the new information, and then again push you as soon as you apply into the state that you desired, that you prescribed with the help of the configuration. Possibly, if whatever possible, it will reuse everything that's already there. If it cannot reuse it, if it cannot reuse it, then it will recreate it, which is pretty cool. So this one does not exist. This guy, I thought I would prescribe it like that and give it a name. Do I have to write the slash? Let's see. Yeah, for whatever reason okay, it's also colon latest. For whatever reason we have to provide nginx.latest. Because it's the name, I guess. But then the colon becomes a dot. This is kind of confusing, to be honest. Not sure how much I like it. I like it that you have to specify this again instead of using just this here. Well, let's plan once more. Clear. Well, let's do the complete thing. We format. It does it automatically in our case because we have the plugin. We validate it. Configuration is valid. We plan. Let's see what it puts out this time. At least our configuration is valid this time. Sorry, excuse me. Just 1 second. T can be dangerous, but it most of the time saves lives. So 2 will be added. Remind that we have actually 3 resources defined now. Resource, resource, resource. But only 2 will be added. 0 will be changed and 0 will be destroyed. And implicitly, so if we go through this, let's make it slightly larger. So we make create on the Docker container, on the nginx, and it will set everything up here the way that we wanted it, as well as health checks, labels, our port forwarding, and the Docker image. But it does not show the AWS instance right now, which is interesting because it has to do nothing. And it uses, again, this state that we have here to determine, everything is fine. And in particular, there's also this refresh command, which is implicitly run when you do the plan. Terraform plan, refresh state, update state, update state with what's actually in the running in the real world. Terraform plan, plan ahead to the target desired infrastructure as defined by configs. And then we have Terraform apply. That's not good. Not really. Anyway. So let's execute. So currently I am running a Docker, a Mongo still from 3 days ago. But in particular, I do not run any containers, any Nginx containers, as you can see. There's also an exited Mongo Express here. Whatever happened to it. But now if we run tf apply again, it will then do the, it refreshes, it plans, and if we do, if we write apply, or yes, approve to the changes, then it will do the magic. And inside, in the case of Docker, it does everything locally. So locally, I will now have Docker running, but at the same time, it's managing AWS for us. So think about it. the power inside of here. Oh, it failed. Well, it would have if it didn't fail. Error response. Invalid container name types of T-time gateway. We are not allowed to use spaces. Okay. Do I use spaces anywhere else? No. Let's put subscripts here, which is kind of the second best solution to spaces, right? Let's do it again. So let's stop here. My bad. Let's see what it actually did. It did not create any containers. Let's cause it to error. Keep locally true. But we intentionally put an error inside of here. I'm curious whether it will still execute this one. It probably will. Or whether it already learns that, oh no, this is not possible. So, oh, you already see. The state says, yeah, now we do updates. So as you can see, it's not 2 to add anymore. It's only 1 to change. But only 1 to add and 1 to change. So it did fail completely with our container, which is why it has to create it from scratch again. But it did manage to do everything for the Nginx, so it doesn't have to do it again. In our case, we do not save the image locally, and that's why it's not visible in Docker image list. But if we do this, so it did change the Docker image, Docker image list, and so it completely executed the resource for that one, but it did not execute the resource for the container. Now, if we if we fix the problem and apply again, now what will happen? Nothing on the Nginx will change this time. On the image will change this time. So it will not update this anymore, and there's also nothing to download. But it will start this container. So we should see 1 to create, 0 to update, and everything is fine. Yeah, now we see it also tries to update the state for the Nginx image. Yeah, 1 to add or create, whatever. 0 to change, 0 to destroy. Go ahead. There it is. And now we can, I think, curl it. HTTP :/localhost 8080. There it is. Nginx is running. You can also do it here. Localhost 8080. That's our Nginx. So that one is already running. Let's put another one in here, just to see some more of the magic. Let's do Mongo latest, and now the interesting thing becomes, because I have it already. I'm curious what it will do. There might be a newer version, I don't know. I'm curious what it will do. We probably have to change the Docker container. Even worse. I mean, I have it running, right? Let's see what it will do. Let's see how clever it actually is. I mean, this is kind of the worst case scenario, right? You have conflicting stuff already running. Database, give it a new name. The port that it's running us on is 2717. Yeah, 27017 here. And I also want to have the port forwarding from there. And that's it, right? That's how we define Mongo. Let's see what it does. I'm curious as well. By the way, if you have any questions, feel free to ask. Also, welcome Twitch Grow Witches in the chat. Hello there. Feel free to say something or say hi. We are doing Terraform today, the basics, as well as fiddling around with it. So it did not apparently notice that I'm actually already having it, which makes sense, right? How should it know? There is no state attached to it yet inside of Terraform, only inside of my system. If we run it, it fails. Unable to start container, error response from daemon, driver failed, program exiting container, port is already allocated. Maybe, let's give it the name Mongo, because that's the name that I have here. Currently I gave it a different, the container, I gave it a different name from what's already running. I'm curious what it will do now. One thing that I do think it did, Docker image list. I think, yeah, that's the same image, right? Same Mongo image. So that worked. even though there was essentially the state already existed on the system, but Terraform didn't even know there was a system to begin with, which is kind of amazing. Let's apply again after we've kind of fixed that this is now identical, 100%, but it's already running. I'm curious. So it does say now only one thing to add because it already has all the images. So everything except for the Docker Mongo container, which failed due to port allocation and a different name. It still fails. The name is already in use. So this is, I think, a Mongo error, right? A Docker error. If we run Docker run all of this, it probably gives us exactly the conflict that the container name Mongo is already in use by container whatever. You have to remove it in order to be able to use that name again. So this is essentially the command that you would run in Docker. So Docker run, which just executes a container. I come to the question in a second. Detached mode, and we want to remove it. I can also no need to do that. The host name is a name. No, the host name is again something else. I'm not sure. The name is the name of the Docker container, and we want to have the port forwarding. Or in this case, we just want to expose the container Mongo port also on my machine. And then I think one of these two is the image. I'm not, either this is the image or this is the image. I'm not sure which one. Yeah, that's exactly the same one. So this error message is actually coming from Docker, and it gets forwarded. Nice. It gets forwarded from the Docker to Terraform, and Terraform prints it to us so we can do something against it, about it. In our case, we can Docker stop Mongo, Docker PS. So now it's not running it anymore. Let's give it a new name, the name that we had earlier. And rerun Terraform apply. Again, getting all the state, or the state that we, refreshing our state that we have saved with what's in the real world. Again, we find out, okay, Docker container as we defined it in the config is not running, the Mongo container. So let's do something about it. Make the desired state make the real world into the desired state, bring the real world into the desired, make the desired state real. That's what I want to say, man. And we say yes, and that's it. Docker PS. There it is. So if I, just to make you aware of this, if I wanted to have still my container running that I had before, I could just change the port. Which one? Okay, the other one. So this one is the internal port and this one is the external port, so this one should work. Or it doesn't. I think the -a Docker container remove RM. Yeah, why would you want to use the full RM remove? So now I can run this with just running it on my local machine with 27 7016. And that works. So now I have 2 Mongos running. Let me zoom out slightly so it's formatted nicer. I have 1 Mongo here, and I have another Mongo here, which is for some reason not called Mongo, but whatever. But it is in the database. Yeah. So that's about it. Let's see, Terraform be like. Is this safe for work? Just, you weren't supposed to do that. The simple image macro of President Trump addressing members of Congress with a aforementioned caption. This meme is starting to take off on social media despite its relatively recent creation. You mean compare with a Docker container or something? Not, yeah, with the problems that we had because we already had 1 Docker container running with that name. Exactly. You weren't supposed to be that to do that. So I took care of everything. That's what Terraform said, except for the one mistake that you made. Please correct it, and then you can try again. But only for this one mistake and everything that in the dependency graph would come after it, of course. So if we had, say, stuff that depended on this T-time, TypeScript T-time database to be up and running, then I'm not 100% sure, but I'm pretty sure Terraform would have taken care of not running everything that depends on it. Okay, time for hydration. Yes, it is time for hydration. Okay, so we kind of did what we wanted to do, right? We do have the EC2 bucket. EC2 instance. We do not have the S3 bucket. Let's find out how we do that. So you would do the tutorial continues, by the way. We kind of only scratched part of it. What else would come? So is the changing stuff. We did do that, in fact. Yeah, we did do that in fact with let's see, the Docker images for Nginx, if I remember correctly. We changed something there, and it used the resource as much as possible. In some cases, it can apply stuff like on the fly. But in some instances, for example, they give an example here where you change the machine image. And of course, if you change the complete machine image, if you want to run essentially a completely different container, then of course you have to completely restart the machine. Amazon is AWS is powerful, but not that powerful of replacing complete operating systems on the fly. So that's this lesson. We pretty much did it. We can also destroy everything. All you do for that, and I actually do run it now, to let you see that we can recreate it within seconds. So we actually destroy everything. Everything will shut down. So it's refreshing now, all of it. So now it just did the planning, sorry. And it had to do a lot of planning in this case. It had to do planning for how to destroy, so everything with a minus will be destroyed. It's very similar to Git. plus our additions minus our removals. And the yellow is as much as possible in process adjustments. So it will remove the AWS instance, it will remove the Docker container, it will remove the other Docker container, the Nginx, the Mongo, and both Docker images. And all I have to do is say yes. Now it's destroying, completed surprisingly fast. The AWS instance, of course, because it's up in the cloud instead of locally, takes a second longer. Can actually follow its progress here as well. So it's shutting down now. Still destroying. Yeah, this just takes a second, right? And we will see in a second. Do we have anything else here? Terraform. Destroy. Remove everything. Defined in context plus state. That's it. So now if we look here, all that's left is a terminated machine. In fact, this will go away like in the next 5 hours or so. It's probably a defined time. So AWS will clean that up. We will not be able, if we run it again, and we will run it again, you will see that it's a different instance that's being created. Because, and now come to that part, the state is actually completely destroyed, as you can see here. Previously, it was kind of a, so it had all inside of the resources, it had both the AWS instance as well as all the other stuff. But now it's gone. And locally, you see, so the Docker container, the Mongo instance that I ran myself on 27.0.16 is still running. So it did not touch that, which is good. And everything else, Docker image list, we still have the images. The Nginx. So it did not clean that up. I'm curious why. There's maybe something like cleanup or remove or RM, maybe. True. Like remove it on destroy. But we would need to look into this provider for more specific information, and well, you can just look it up. The Docker provider uses this. There's the image. We have a kind of nice documentation here about how the image works. Keep locally, force remove if true. Yeah, force remove is apparently what we were missing here. If true, then the image is removed forcibly when the resource is destroyed. So yeah, everything was removed essentially, except according to what we defined how it should be removed. Let me click that link here. Using Terraform for Docker. We weren't supposed to do that. Why not? It's essentially a replacement of Docker Swarm or Docker. Well, Docker Swarm, not really. Not really Docker Swarm. More that would be more in the Kubernetes direction. But Docker Compose. You didn't create that, right? or did you just create it for this purpose? That will be rad. Let's see. Oh, we have a few more people in the chat. Hello, another TV viewer. Hello, Joseph. Joseph Seven. I hope I pronounced it correctly. Welcome to our stream. Welcome to the TypeScript tea time. We are drinking tea, and in the meantime, we are looking today at Terraform. So we not only do TypeScript, we do everything nerdy. Today we look at Terraform as well, integration with it. So we kind of follow the tutorial roughly. For AWS, we provided some configurations, looked at how to install it, everything, and set it up, as well as spin up an EC2 instance, like a virtual machine essentially, with this snippet of code. We also at the same time, so this happens inside of AWS, while all of this we actually do locally. We also looked at Docker, how to spin up multiple images and essentially replace Docker Compose to a degree, if you want to say it like that. Let's see. One thing that I do want to do now. Did I miss something here? Oh yeah, we fixed all the bugs, like so. Now the magic happens, and I was saying at the beginning. Let's see, maybe we have a meme for that. Infrastructure as cattle, not pets. To all the people who are vegetarians or vegans, I apologize for that. Pets versus cattle. Yeah, so we want this. All of our EC2 instances and Docker containers should just be as removable as possible. Of course, everything that's stateful, we don't want to remove. But let's say we want it to be still to be as replaceable as possible. So of course the data is not replaceable, but the MongoDB sitting on top of that data, that should be replaceable, in fact, ideally. How to explain why cloud is different, and it's about uniqueness. Yeah. So there are a lot of memes on that front as well, apparently. Pets, legacy infrastructure, cloud-friendly infrastructure. Can we see that? Cattle are given a number. They are almost identical to other cattle. When they get ill, you replace them and get another. Not nice, again, but that's how it is. Infrastructure is as much as possible stateless. Ephemeral, which means like short-lived in the sense of you don't intend to have it forever. And transient, I'm not 100% sure. It's instantiated, modified, destroyed, and recreated in minutes, and we will do that just now. TF apply. Do the magic. Well, now it refreshes again, but there's nothing to refresh because the state is empty. It plans again, and in this case, nothing exists because, the state is empty. So it has to create everything, every single resource, the 2 images, 2 containers, and an EC2 instance. And yes, we want to do that. Do the magic for us, and in a few seconds, like Docker is rather fast. As much as I've seen so far, the EC2 instances, these basic ones take like 30 seconds. to spin up. So in 30 seconds, we have everything recreated from scratch. Except, well, we installed Docker on this machine as well as Terraform and AWS CLI. But everything else. So let's wait for that, and then we head on to the creation. Yeah, let's look at this for a second. There they are. TypeScript T-time database is up again. TypeScript T-time gateway is up again. Again, if you really had data inside of here, you would need to do some more intricate stuff. Instead of just removing everything. Just remove all your user data. I don't care whether it's worth $16 million dollars or euro, wherever you are, or pound or yen. Well, 16 million yen is not that much. Well, it's still a lot, but it's not that much. 16 million times 100 yen. Then it's much. So we have this again. We have, well, for typo, it had to do nothing here, but let me send this to you because it's so not nice. I want to send it to you. Random post. I don't know what else they wrote, but the picture was pretty good. If we now go to localhost 8080, it's still up again, or it's again up, let's say. So it, from our perspective, it looks like nothing really happened, but in the meantime, actually the complete server was gone and completely got recreated. And inside of here, we will now see two. I should get used to clicking this button. There's our new TypeScript T-time. TypeScript T-time is awesome. Yeah, it is. But it has new data, of course. So it has a new IP address attached to it because it was completely recreated. That's pretty much it. From the very, very basic and essential ideas. Other than that, stack awesome. Yeah. Other than that, you can make this slightly more, let's say, not functional, but yeah. If you, I mean, what do you do? Usually, if you write a function in JavaScript, let's say, JS, my func, you do stuff console.log 1, 2, 3. Usually you want to have it dependent on stuff, and you want, why do you write functions? You could just make one massive script in single file, ideally. Worse, in single file right here, 900,000 lines. You could do that like so, but it's not really useful in the sense of reusage. Instead, what do? You put it inside of a function and make it dependent on a variable, some input, and then you can do my func of whatever, and it works. And you can do that in Terraform to a degree as well. This is where input variables come into play. So you have to define them like so. So there's a separate keyword for that. And in this case, it's the instance name, which we could parameterize. And then whenever you run Terraform apply, let's do that, man. Stop talking, do it. No, our goal is slightly different. So what do you guys think? Follow this plan and do the AWS S3 bucket, or look into input variables? You decide. In the meantime, I try to find the S3 bucket. AWS Terraform S3. Yeah. Module? That's not it. This one. Awesome. Chat, I need your help here. Follow the plan and do S3. S3 it is. So what I was saying about parameterizing is one part. You can, although I'm not sure about that too much, to be honest. There's something called modules, Terraform modules, and they are also shared. For example, this S3 modules, and I think they are basically like functions, depending on variables. So this one has a variable dependency, AWS greater than 327, 338. This is okay. Yeah, let's try to find the S3 one. This one. That's the same one? Probably. Did it work? This one? Top downloaded. VPC, security groups, EKS. Oops. How do I don't want to see the username. Come on. Yeah, so this is new territory for me as well. Apparently, you can use it like this. Copy and paste into your Terraform config. Sounds good to me. And then let's look at it. So we put it inside of here, and we put it, let's say, at the very bottom. Module S3 bucket. Okay, fair enough. It uses Terraform. So this is the source, which just pulls it probably from here. And other than that, we define a version, which is fine by me. We can look at examples even. Nice. All on this page. Did I share that? Yeah, I did. No, did I? No, this is a different one, right? It looks different. Take that one. No, it's the same one. It's the same one after all. My bad. So let's look at the examples. So a complete S3 bucket with most of supported features enabled. Okay. Configuration in this directory creates S3 buckets which demos such capabilities as static website hosting. Yep. So we can put HTML inside of there as well as other stuff. Course is set up because by default I think you have course policy to be blocked, so there are no access allowed headers. If you guys want to, we can look into course at some point, which is one topic that many people struggle with, particularly if they try to set up their first web servers. And it's actually not that hard if you know that you need to look at on the server side instead of the front end. Lifecycle rules, server-side encryption, object locking, and grants. I don't know what grants are. I also don't know what this is. Or lifecycle rules. Yeah, there's a lot to learn with AWS. Please check replication for cross-region replications. We don't need that. Note that this may create resources which cost money. Run Terraform destroy. Yeah, it does cost money, but if you destroy it in time, and I think we used like 3 hours, so it cost me probably like €1, everything that we did. So we can use the model with the help of this. Insert the 5 required variables here, but which are, I think we get auto-completion as soon as we write, not npm, Terraform init, because it has to initialize the module this time. And everything else can be reused. And now we can do Terraform plan. Let's see what it does. It wants to create a resource which blocks public access. Wait. Wait, what? Are we supposed to copy this? Unknown. Known after reply. I think we can copy and paste this, right? Can we? It is talking about like 5 variables, so I suppose these are the 5 variables. Do I get auto-completion by now? I don't. That's too bad. What are the 5 variables? Resources, output, inputs, no input. It has input, doesn't it? Input 0. If it's complete. Outputs 5. Yeah, so there are inputs and outputs, by the way. Outputs is like if you if you want to change stuff and you want to print out the, I don't know, if we go back here, it just said apply completed. But for example, if you need the, let's say, Docker ID, the Docker container ID, or the public domain, the public DNS name, or the public IP of your EC2 instance, you can print that out with the help of output variables. That's also in this first query data with outputs in the getting started guide for AWS. Other than that, let's try to find out how we. So I'm saying this because this module automatically outputs 5 things: object ID, etag, blah 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 blah. Oh, this one you have 8: the domain name, regional domain name, and so on. What I'm confused about is the 5 variables they were talking about, which are not written here. Maybe if we go back to the module, here, inputs, required inputs, acceleration status. I have no idea what that's supposed to be. Can be enabled or suspended. Is there a default? Let's just enable it. What does it do? Yeah. So again, this is the part where it gets very, very specific to the actual stuff. Static web hosting. That looks good. Bucket, ACL, public read. That looks very good actually. Even CORS. So this could also be something interesting. I would prefer to use our module though. For now, let's say. The bucket, which is the name, equals, so let's call it TypeScript subscript tcup or tcan. No, tcup, because it's a bucket. Bucket prefix is optional. The bucket, wait, what? Description optional. If it's optional, why does it say required inputs? I think this is wrong. Or I don't know what this is, why it's saying optional, whatever. The policy, I think we can copy it from here. The policy should be something like public read policy grant. Ooh, this is getting more complicated. Oh yeah, this is getting more complicated, guys. Private bucket with tags. So we can do a private bucket if you guys don't mind. Routing rules, using CORS, using versioning, enable logging. ACL, this is it. ACL public read. So this has to be like so, this has to be like so. Save. Do we need this? I'm not sure. Let's see. What happens if we try to apply? Maybe we have to copy all of this. So ACL, by the way, stands for access control list, which means who has access. By default, it's just private, so you can write to it with the help of the AWS CLI, or if you like the ClickOps, you can put stuff inside of there, but nobody can access it like via the internet, the regular IP. So the name is invalid, only lowercase alphanumeric characters, so this one needs a minus. Again, I said my argument still stands. It's to a degree. It's to a degree provider agnostic, but things like these are just so specific to a provider. Yeah, do the magic. What else do you do? Did we also create a... Yeah, it's publicly readable. And its name is TypeScript tcup. Sounds good to me. And everything else seems to be optional. Yeah, do it. To a degree. So I know the end result that I want, but to a degree I feel like this right now. It did something. It did not put out the output, but that's okay. I can live with that. It did something, and let's see. Inside, not our instances, but we have to look for S3. Scalable storage, yeah. And this is also bound to a place. Let me move back to, apparently S3 does not require a region to be selected. Yeah, thank you, I will do that at some point. Thank you. No, the design is not, the design is not very friendly with being adjustable. Where TypeScript T-Club, it's public. It does not have any objects inside of it, but if I upload a file inside of here, let's see, for example, E6, it's inside of here, go inside of there, go inside of Terraform learning, no, T and TypeScript Terraform, not the state, but let's say I will put this one into main TF anyway. Emoji, yeah, keep them emojis coming. Did it already upload? No, not yet. So the whole bucket is public at this point. So what I think is that the file should just be available. No, it's not. Or is it? Let's see. What does public access actually mean? Do we have to? Public ACL S3 meaning. Enable you to manage access to buckets and objects. Each bucket and object has an ACL attached to it as a sub-resource. Okay. What does it mean? What do I need to know? Yeah. Oh man, this is not better. Let's see. It was originally designed to be public, so S3 in general. It is still public in a lot of cases. How do I access the file? How do I access the bucket? Let's ask like that. Access points. We have no access points. Maybe that's the issue. Access public. This bucket can be accessed by anyone on the internet, unless you require specific configuration for a specific verified use case. In AWS, it's recommended that you do not do this, but instead do it slightly different. What I'm still confused about is how do I actually access it? Because this file here is actually not, or is it? Maybe. No, it's not accessible. If I go to here, so apparently it is accessible and it has contents, but the contents itself are not accessible. Great, thank you. Thank you for nothing. Yeah, so we would need to do a deep dive into how to also make all the sub-resources public. I do know I can do it on an ad hoc basis by just, I think, clicking here or just selecting the file, go to permissions, and can edit here, for example, public object ACL. Which one of these? I suppose this one. Yeah. Getting an understanding of the great. I was about to say, getting an understanding of all the security and IAM roles and access control lists and what does mean what on AWS is like a complete seminar probably in itself, and I should look into it more, and I want to, but it's so damn boring, I think, to be honest. Maybe there are some good and nice blog articles. Definitely the AWS documentation is terrible, I am telling you. So I am actually not allowed to click this button, but I do it anyway, because in 5 minutes I would just destroy anything anyway. So I'm fine with it. Let's do that. And from now on, this is accessible. Bam as well. And in fact, I can also do it inside of here, and it automatically downloads the file. P3, let me look at it first to verify everything is fine. Yes, this is public. So P3, if you want to look into it, you have like 5 minutes left until I destroy it again. And yeah, but that's pretty much it.